Hello, it's Angela here. I'm just giving feedback on the KA1 that you completed on the 15th of September. So I'll go through page by page and we'll talk about each question. And please make corrections in a different colour on your own script, okay, if you got the answers wrong. Okay, so the multiple choice questions. This is just a definition of a molecule, which you should all know, that molecules are covalently bonded groups of atoms. Relative isotopic mass, again, is a definition. Basically, don't forget about the 12th of the mass of carbon-12. An isotope, again, another definition. You know, you've got all these definitions in your books, my students anyway, my group. And you need to learn them. Okay, looking at these equations, which one is not balanced? You know, quick glance through, you can see here we've got 7 oxygens on this side and only 6 on this side. Okay. Displacement means you would have done this at GCSE, I think, this kind of displacement idea. If we look at these equations, whereas one metal displaced another, it's only equation D, where you've got magnesium has replaced copper in the solution of copper sulfate. The copper sulfate solution is now magnesium sulfate, and we've now got copper solid or copper metal. Question 5, atomic structure, basic stuff. What does a nucleus of a sodium atom contain? 11 protons, 12 neutrons. I mean, you're given the mass number there, so 23 minus 11 is 12. Mass spectrum calculation here. Okay, so, you know, you've got multiple choice, so you know you're going to get one of these answers. It has to be exact. So, okay, it might not be absolutely easy to see that this is 70% and 30%, but if you do the calculation, it comes out at 63.6, then you know that's the right answer. They're going to make it something straightforward, if it, you know, because it's not on graph paper or anything. So the fact that they've got 70 and 30 here is a good indication that that's the percentages you should be using. Question 7, the ionic equation. Basically, if you know your ion charges, obviously it's saying that barium chloride and potassium sulfate are mixed, so we're going to get barium sulfate. So it's just a matter of knowing that barium is 2+, sulfate is 2-, so it'll be BaSO4. Can't be this one, and it's not going to be potassium chloride. Okay, question 8. Yeah, pair of isotopes is really recognising the definition of an isotope. Lead has 82 protons, different numbers of neutrons if it's an isotope. So none of these represent isotopes because you haven't, in the sulfur here, you've got a sulfur ion with the same number of neutrons, and again here we've got carbon and nitrogen. They're obviously not isotopes, they have to be the same element. Okay, question 9, straightforward definition of what is an isotope. So if you recognise these, you should be able to write this definition. Why do isotopes of carbon have the same chemical properties? It's important to recognise that any chemical reaction, it's only the electron in terms of particles in the atom that is involved in the chemical reaction. So isotopes of carbon have the same number of electrons, hence they will have the same chemical properties. Only the neutrons that change in an isotope, isn't it? Okay, basically learn this definition, relative isotopic mass. Can't say more than that. Okay, question 10, write a balanced equation. Now you should know these formulae, the formula for ammonia, the formula for sulfuric acid. You should know them off by heart. You'll have done them at GCSE. And recognise that if you add an acid and an alkali together, we get a salt. Yeah. But you need to recognise that NH4 is +1. Yeah, so we need 2 of them, and SO4 is -2. So when you write the formula, NH4 in brackets 2 SO4. It's got it even down here, look. And then it says, but obviously you need to balance the equation. That's the crucial thing. Give your answer to 1 decimal place, very important. Follow the instructions in the question. So you're just adding up the relative atomic mass of each element in our ammonium sulfate, and to 1 decimal place is 132.1. Okay, group 2 element, barium. So you know group it's in group 2, so it's going to form a 2+ ion. And it tells you that the nitride ion is N3-. So even if you're not familiar with nitride, it's got it written in the question. So use that information. So the formula, oxygen forms a 2-, Ba is 2+, so BaO. And here we've got 2+ and -3, so we obviously need to multiply them up. But if you don't know your ion charges, you will find these questions extremely difficult. So please, I cannot stress enough how important it is that you learn this basic information. State the formula of the calcium compound formed when calcium oxide reacts with water. So this is a bit like sodium oxide, you know, group 1 element. This is just that calcium is a group 2 element. It's going to form a hydroxide, but calcium is 2+. Again, you've got to know the ion charge. And your OH is -1, so you're going to need 2 of them to get the correct formula. Same with your nitric acid. The nitrate is -1, calcium is +2. There you go. Okay, so we are asked here to balance an equation where we've prepared an aqueous solution of calcium chloride reacting calcium with hydrochloric acid. Yeah, so metal plus an acid gives a salt plus hydrogen gas. Some of you put here 2H, but hydrogen is one of those diatomic molecules. In an equation, it's always written as H2, not 2H. Okay. All right, this is asking for state symbols. So here we've got a solution. So if it's a solution of something, it's going to be aqueous. Your sodium carbonate is aqueous. Your sodium chloride is aqueous. Your carbon dioxide is going to be a gas. Of course, your water is going to be a liquid. That's pure substance. Whereas these, aqueous, 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 they are substances that are dissolved in water. Yeah. Okay, this is important to state what you would see. Okay, so you know it's got to be something that you would see with this reaction. You know that a gas is being evolved, so you will get bubbles forming, or effervescence is another word that is often used to describe a gas being evolved in a chemical reaction. Okay, question 15. It tells you this is a group 2 element, radium. Hence, you should know straight away from that it will form a +2 ion. If it reacts with chlorine, chloride is a -1 ion, so you're going to need 2 of them. Comes back to the old ion charges. Oops, I've forgotten to fill this one in. Okay, so we've got magnesium, which has 12 protons, and we'll have 12 electrons. The only thing that's going to change is the number of neutrons. Yeah, so this is basic atomic structure, recognizing that the proton number doesn't change, the electron number doesn't change, only the neutron number changes. Okay, we're given some information, some data on a sample of magnesium, and we are asked to calculate the relative atomic mass and give the answer to 4 significant figures. So the calculation is straightforward. You take your isotope, the mass number, multiply by the percentage abundance, add them all together, divide by 100, and come up with this value. And then we have to round up to get 4 significant figures. Yeah. Okay, relative atomic mass, please just learn that definition. And again, isotopes, learn the definition. Okay, so this time it's just it's the same calculation for relative atomic mass, but you're given, you know, a mass spec readout giving you your percentage abundance. Yeah, so you have to read it from the graph. So you have to make a decision. Obviously, is this 71? Is this 72? Yeah, or whatever. But whatever you put here, they have to add up to 100. So some of you didn't ensure that if it's a percentage, then they must add up to 100. Yeah. So in the mark scheme, you were given, you know, the option of putting 70, 71, 72, you know, but then the corresponding percentage underneath. Obviously, the protons and electrons are going to be the same for rubidium, only the neutrons will change for the different isotopes. This is basic atomic structure, which you should know without really thinking about. And then, depending on the numbers you put in here, you calculate your relative atomic mass, and then you round it to 3 significant figures, which is what is asked for in the question. And the scale, the relative scale that we use, is all based on carbon 12. Okay, don't forget that. Right, okay, again, this is relative atomic mass, calculation, isotope, percentage abundance. The instrument that we use to measure the different isotopes is called a mass spectrometer. So if you don't know that, make sure that you've learnt it now and you've written it down somewhere. And you can work out using the same procedure as we've done in the previous questions. We've come up with a relative atomic mass of 63.5, which, if we look on our periodic table, corresponds to copper. Okay. And then the final question, again, was a basic atomic structure question. Looking at, you've got a sodium ion and a chloride ion here. It's asking you the mass number, which you take from, you know, the bigger number. The number of neutrons was obviously 23 minus 11. Here, 35 minus 17. But of course, this is a positive ion, so it will have 1 less electron. And this is a negative ion, so it's going to have 1 extra electron. Yeah. And then the overall charge here will be +1, and the overall charge here will be -1. And then you're just asked here to write using the same notation for an ion with 16 protons, 18 neutrons and 18 electrons. So if you look that up on the periodic table, you know that it's sulfur. It's in group 6. So if it's got 16 protons but 18 neutrons, then the mass number will be 34, and we will have a 2- ion, yeah? Because it's got, instead of 16 electrons, which you would expect, it's got 18 electrons. Yeah, so it's got 2 extra electrons. And that is the end of the feedback for KA1. And I'd just like to see that you've made corrections on your original script in a different colour to that you wrote in or that I've marked in. Okay, thank you very much and good night.